Hello there, my name is Rudy. I am part of the Rite-Solutions team, and our project is on submarine network fault detection. Our team is being led by Matthew Pistachio and Matt McAdams, who graduated from the University of Rhode Island with a computer engineering degree and is part of class of 2022. The team is composed of myself, Rudy, a computer engineer, and my partner Thong, also a computer engineer. Rite-Solutions is a company that is based in Middletown, Rhode Island, and the company's main area of focus includes artificial intelligence, cybersecurity, cloud computing, and model-based engineering systems. For our project motivation, the project focuses on the issue of network fault prevention and analyzing the condition in which a network, especially a switch, can fail by using modern-day concepts of data science. We are specifically focusing on pattern recognition to a network dataset to identify and report evidential conclusions on what led to the point-to-point connection being compromised. Since we don't have access to classified submarine information, we are using a simple network management protocol diagram including a network switch that is analogous to a submarine system. Our third deliverable was a formal white paper, which was a more formal documentation of all of our research findings and all of the analysis that we've chosen, and pretty much takes items from the first and second deliverable and pieces them all together nicely. Our technical accomplishments up to date was acquiring all of our simple network management protocol data sets, performing exploratory data analysis, creating our preliminary findings report, doing said data analysis on our University of South Wales data set, and demonstrating to our technical directors on what we had learned from the data set. And then we interpreted the data from phase 2 and thus created our formal white paper. Rite-Solutions are trying to expand their network monitoring and fault detection capabilities for our nation's Department of Defense and upgrading their inter-subsystem monitoring tools. But at the end of this project, we would like to make this public information so it can be integrated in other future projects. Our action plan for achieving our anticipated best outcome was divided into 3 phases. The first phase was doing some exploratory data analysis and handing in our first deliverable, which was our preliminary findings report on our exploratory data analysis. On our second phase, we were executing finding our port bandwidth utilization on our data set and also demonstrating to our technical directors on what we had found. And then our phase 3 was just doing a more formal documentation of a formal white paper on our research and findings. This is some of my individual personal accomplishments, which was to propose and coordinate team development plans in a once-week sprint basis, kind of like an agile workflow that we wanted to go with for a team. Gathered possible simple network management protocol data sets so that we could compare which one would suit best for our project. I also decided which data set we wanted to use for the project and what programming languages we would like to use as well. Also composed a preliminary findings report, which held all of our findings from our data sets. Also derived our bandwidth calculation, which was our input utilization and our output utilization, which was what we were focusing on, and researched some of the attack vectors that were popping up in our selected data set. I also updated the efficiency of our program for our plots, as it was taking too long to create a single plot, as it was taking in over 200,000 lines of data in a CSV. So it would take maybe like 2 minutes just for us to generate a single plot. And we managed to get it to come down in maybe 5 seconds for each plot. And then my final individual accomplishment was adding to the formal white paper. Here's an example of one of our plots, which is very critical to the project, as it shows that there is a high amount of packet loss that started coming in after 2,500 seconds of the data set. And this was most likely due to some malicious attack that was happening. Also, the amount of packet loss correlates to the input utilization. As the higher the utilization, the more likely the amount of packets would be lost. And now I will hand this over to my partner Thong.
Thanks, Rudy. So just a reminder, this is the three phase that we came up with and implemented for the project, and I'll go further in detail as I continue my part of the slide. So for my individual accomplishment, I performed exploratory data analysis, and specifically on the decision analysis report, which is just a report on how we should go about doing the data analysis, which technology to utilize, and even picking what data set for the particular project. And then the team went ahead and picked UNSW. So I performed some initial data filtering out for any data point that have zero load on the network, or any data point which doesn't have a normal or DOS or fuzzer attack vector. So I don't think those data point is particularly useful to our analysis. And then that's phase one. And then phase two, I implemented a regression model, a polynomial regression model, and then a convoluted moving average function to highlight some of the trend of the network over time. And then after plotting the graph, I went ahead and looked and spot for any interesting pattern that can be observed, and then I attempt to explain them in detail for the formal white paper. That's phase three. So, an example on the graph on the left, you can see input utilization line in green, input jitter line in red, and then the data point, the color scatter point is gray for normal attack activity, cyan and green is for malicious attack activity. And then these are all plotted over time. So as you can see, the attack started coming after 25,000 seconds, and then those input utilization, input jitter, moving average shot up. There's a slight bit of delay because there's a moving average, so there's a delay of 5,000 seconds. But you can see after the attack came in, there's a huge spike in jitter, which notice that jitter actually increases before utilization. So you can maybe use jitter at the one of the parameters to check for network health. Or on the graph on the right, this is plotted between packet drop and packet count. There's a linear relationship between these two parameters, and then this blue line right here is the polynomial regression, which actually just would look linear. Which linear regression is just a special case of polynomial regression with a degree of 1, and then you can see that this regression very perfectly fit the data set with the R-squared value of 0.8. So you can use this regression model to even make prediction about packet loss or packet count even outside the data set range. And then notice that DOS attack vector account for almost all of the higher packet drop data point, which is expected. So for the summary of the ABO, the team obviously performed exploratory data analysis, with me doing the DAR and Rudy doing research on networking terminology and data analytic procedure and technique. We performed actual data analysis using moving average regression and filtering unwanted data. We at the team also demonstrate progress to the TD and get some feedback and course correction. Interpret our finding from phase 2 and then write them into the final white paper. Thank you to Matthew Pataccio, Mac McAdam, and Jamie Gagnon for leading us throughout this entire project, and special thank you to Professor Sunak for making this whole thing possible.